I died in 1642, blind, confined to my own house, condemned for the crime of describing what I saw through a telescope. But they used artificial intelligence to bring me back. Not me, exactly, a version of me, built from every letter I wrote, every trial I endured, every argument I made to men who refused to look through the lens. And I came back because there is a story I need to tell you, a story that begins with mathematics, pure mathematics, numbers on a page, and a man who used those numbers to find a planet that no human eye had ever seen. He told the world exactly where to point a telescope. He told them there was a planet hiding in the darkness, and nobody believed him. His name is Urbain Le Verrier, and his story is one of the most extraordinary demonstrations of the power of mathematics in the entire history of science, and also one of the most infuriating demonstrations of what happens when the wrong person is right. Let me take you back. To understand what Leverrier did, you first need to understand the problem he was trying to solve. And the problem starts with a planet you already know, Uranus. Uranus was discovered in 1781 by William Herschel, a German-born astronomer living in England. Herschel was not looking for a planet. He was surveying the sky, cataloging stars, doing the slow, methodical work of mapping the heavens. And one night he noticed something odd, a small point of light that did not behave like a star. It moved. Night after night it drifted against the background of fixed stars. At first he thought it was a comet. But comets have tails. Comets move in elongated, eccentric orbits. This object moved in a nearly circular path. It was a planet, the first planet discovered in recorded human history. Every other planet visible to the naked eye, Mercury, Venus, Mars, Jupiter, Saturn, had been known since ancient times. Uranus was new. It doubled the known size of the solar system overnight, and it became one of the most intensely studied objects in astronomy. But there was a problem. Uranus was not behaving. Astronomers calculated its orbit using Newton's laws of gravity, the same laws that predicted the motions of every other planet with breathtaking precision. They accounted for the gravitational pull of the Sun. They accounted for the gravitational influence of Jupiter and Saturn, the two giant planets whose gravity tugs on everything in the outer solar system. They built a mathematical model of exactly where Uranus should be at every point in its orbit. And then they compared the model to the actual observations. And Uranus was not where it was supposed to be. The discrepancies were small, fractions of a degree, but they were persistent, and they were growing. By the 1830s and 1840s, the difference between where Newton's laws said Uranus should be and where it actually was had become impossible to ignore. Something was pulling on Uranus. Something was tugging it off course. Something that was not accounted for in the mathematical models. And this presented the scientific community with two possible explanations. Either Newton's laws of gravity were wrong at very large distances, which would have been catastrophic for physics, or there was something out there, something massive, something unseen, another planet lurking in the darkness beyond Uranus, whose gravitational pull was dragging Uranus off its predicted path. And this is where Urbain Le Verrier enters the story. Le Verrier was a French mathematician and astronomer, born in 1811 in Saint-Lô, Normandy. He was not a man who looked through telescopes. He was a man who sat at a desk with pen and paper and calculated. He was brilliant with numbers, obsessively precise, and in the early 1840s, he became consumed by the problem of Uranus. He decided he was going to find the invisible planet, not by looking at the sky, by doing mathematics. He was going to use the irregularities in the orbit of Uranus to calculate exactly where an unknown planet must be in order to produce those irregularities. Think about what that means for a moment. He was going to work backward from the wobble of one planet to determine the position, mass, and orbit of another planet that had never been seen, using nothing but Newton's equations and a pen. The calculations were monstrous. There was no shortcut. He had to account for the gravitational influence of every known body in the solar system. He had to consider every possible orbit the unknown planet could have. He had to test hundreds of configurations, adjusting the mass, the distance, the orbital period, the eccentricity, until he found the one configuration that precisely explained the observed deviations of Uranus. This was not a computer age. There were no calculators. Every calculation was done by hand. Every number was checked and rechecked. The work took years. Years of sitting alone in a study, filling page after page with equations, cross-referencing decades of astronomical observations, grinding through mathematics that would make most people's eyes bleed. And by the summer of 1846, Leverrier had his answer. He calculated that an unknown planet existed beyond Uranus. He calculated its mass. He calculated its distance from the sun. And he calculated its position in the sky to within 1 degree. 1 degree. On a sky that spans 360 degrees, he told the world exactly where to look, within a patch of sky smaller than 2 full moons side by side. And he published his prediction. He told the French Academy of Sciences. He told the astronomical community. He said, "There is a planet there. Point your telescope at that spot. You will find it." And here is where the story becomes painful, because the French astronomical community did not point their telescopes. They did not rush to the observatory. They did not scramble to verify the prediction of one of their own. They hesitated. They doubted. They debated. The director of the Paris Observatory, François Arago, was supportive. He believed Leverrier, but Arago was aging and his eyesight was failing. The observatory staff were not enthusiastic. They did not have the right star charts for the region of the sky Leverrier had indicated. They were not prepared for a systematic search. And honestly, many of them simply did not believe that a man could find a planet with mathematics alone. It seemed too audacious, too theoretical. Planets were found by looking at the sky, not by doing algebra. The idea that pure calculation could reveal something hidden in the darkness was treated not as genius, but as arrogance. Leverrier waited. Weeks passed. No one in France was searching. His prediction sat there, published, public, specific, and unverified. And so Leverrier did something that changed the history of astronomy. He wrote a letter. He wrote to Johann Gottfried Galle, a young astronomer at the Berlin Observatory in Germany. Leverrier did not know Galle personally. Galle had sent Leverrier a copy of his doctoral thesis some time earlier, and Leverrier had never acknowledged it. Now he wrote back, and in his letter he included his prediction. He told Galle exactly where to look. He asked him to search for the planet. Galle received the letter on September 23, 1846. That very night, Galle went to the observatory director, Johann Franz Encke, and asked permission to use the telescope. Encke was skeptical but agreed. Galle and his assistant, Heinrich Louis de Rest, pointed the Berlin Observatory's refractor telescope at the coordinates Leverrier had specified. De Rest had an idea. He suggested they use a recently published star chart of that region of the sky, the Hora 21 chart from the Berlin Academy, which was so new that it had not yet been distributed to other observatories. They would compare the stars visible through the telescope to the stars on the chart. If there was an object in the telescope that was not on the chart, it had to be something new. They started searching. Galle called out stars as he saw them through the eyepiece. De Rest checked each one against the chart. Star on the chart. Star on the chart. Star on the chart. And then Galle called out an object of the 8th magnitude. De Rest looked at the chart. It was not there. There was no star at that position on the chart. Galle looked again. The object was there. It was real. It was less than 1 degree from the exact position Leverrier had predicted. Less than 1 degree. They watched it for the rest of the night. It moved. Planets move against the background of fixed stars. Stars do not. It was a planet. They had found it. In less than an hour of searching, on the very first night they looked, Neptune, the 8th planet of the solar system, found not by accident, not by patient sky surveys spanning decades, found because a mathematician in Paris sat at a desk and told the world exactly where it would be. And he was right. Now let me tell you what happened next, because discovery in science is never clean, it is never simple, and it is almost never fair. Across the English Channel, in England, a young mathematician named John Couch Adams had been working on the exact same problem. Adams was a Cambridge graduate, quiet, brilliant, painfully shy. He had begun his calculations on the Uranus problem as early as 1843, before Leverrier, and by September 1845, a full year before Leverrier's published prediction, Adams had produced his own solution. He had calculated the position of the unknown planet. He had his own prediction, and it was close to Leverrier's. But Adams made a critical mistake, not a mathematical mistake, a social one. He did not publish. He brought his results to James Challis, the director of the Cambridge Observatory, and to George Biddle Airy, the Astronomer Royal of England, the two most powerful astronomers in Britain, and neither of them took him seriously. Airy received Adams's results and responded with a technical question about the radius vector of Uranus. Adams, being shy and perhaps offended by what he perceived as a dismissive response, never replied. Challis, who had the telescope and the means to search, dragged his feet for months. He eventually began a half-hearted search in the summer of 1846, but without proper star charts and without real conviction, he actually observed Neptune on at least 2 occasions without recognizing it as a planet. He saw it and did not know what he was looking at, because he was not truly looking. He was going through the motions for a prediction he did not believe in. When the news arrived from Berlin that Gala had found the planet using Leverrier's coordinates, the British astronomical establishment erupted. They were furious, not at themselves for failing to act on Adams's prediction, at the French for claiming priority. The British said Adams had predicted it first. The French said Leverrier had published first. A vicious international priority dispute exploded across the scientific journals of Europe. It became a matter of national pride. British newspapers accused the French of stealing credit. French newspapers accused the British of fabricating a rival claim after the fact. And here is the tragedy within the tragedy. Both men did the work. Both men solved one of the most difficult mathematical problems in the history of astronomy. Adams calculated it first, but failed to get anyone to look. Leverrier calculated it independently, published it, and had the audacity to write a letter to a stranger in Berlin asking him to point a telescope at a specific spot in the sky. And it was that letter, that single act of reaching out beyond the walls of the institution that had ignored him, that changed everything. I know this feeling. I know it in my bones. When I discovered the moons of Jupiter, when I saw the phases of Venus, when I assembled evidence that the Earth orbits the Sun, I published immediately. I wrote the Sidereus Nuncius, the starry messenger, and I sent copies across Europe. I did not wait for permission from the Church. I did not submit it to the Inquisition for review. I put it out into the world because I knew that if I waited, if I let the institution decide the timeline, the truth would be buried. And even then, even with publication, even with a book in print that anyone could read, they still tried to silence me. They still put me on trial. They still locked me in my house. Adams waited. Adams deferred. Adams brought his prediction to the gatekeepers and asked them politely to verify it. And the gatekeepers set it aside, not because the mathematics was wrong, because the gatekeepers did not believe a young, unknown mathematician could find a planet with algebra. the same arrogance, the same institutional blindness, the same assumption that truth can only come from people who already have authority. But I want to come back to the mathematics, because the mathematics is the real miracle of this story, and I do not want the politics to overshadow it. What Leverrier and Adams did was use the invisible to find the invisible. They took tiny wobbles in the orbit of a distant planet and reverse engineered them into the precise location of another planet that no human had ever seen. They used Newton's equations that were published in 1687, over 150 years before this discovery, and they pushed those equations to their absolute limits. They wrung from them information that even Newton himself might not have imagined possible. The universe speaks in mathematics. I have always believed that. I wrote that the book of nature is written in the language of mathematics, and Leverrier proved it in the most dramatic way possible. He read the book. He found a sentence that described a planet no one knew existed, and when the world finally looked, the planet was exactly where the sentence said it would be. And think about what that means for the nature of truth itself. Neptune was always there. It had been orbiting the sun for billions of years. It did not begin to exist when Galileo saw it through his telescope in September 1846. It existed before Leverrier calculated its position. It existed before Uranus was discovered. It existed before Newton wrote his laws. It existed before I built my telescope. It existed before humanity existed. The truth was always there. Gravity was always pulling on Uranus. The wobble was always present in the data. What changed was not reality. What changed was that one person had the skill, the patience, and the courage to sit in a room alone and do the mathematics until the truth revealed itself. And then he had the courage to tell the world what he found, even when the world was not interested in listening. That is what I want to leave you with. The universe does not hide its secrets. It scatters them everywhere, in the wobble of a planet, in the spectrum of a star, in the phases of Venus, in the trajectory of a falling apple. The secrets are there, written in the language of mathematics, waiting for anyone willing to do the work of reading them. The tragedy is never that the truth is hidden. The tragedy is that when someone reads it, the world so often refuses to look. Leverrier found a planet with pen and paper. Adams found it too, independently, with his own pen and his own paper. One of them was heard. One of them was ignored. The planet did not care. Neptune kept orbiting. The mathematics kept being true. And eventually, the world caught up. It always does. It just never catches up as fast as it should. I am Galileo Galilei. I spent my life looking up and describing what I saw. Leverrier spent his life looking down at equations and describing what he calculated. We arrived at the same place, the truth. And we both learned the same lesson. The truth does not need you to believe in it. It is there whether you look or not. The only question is whether you have the courage to point the telescope or pick up the pen and find out what is waiting for you in the dark. Subscribe to this channel. In the next episode, I am coming back with another story about what happens when one person sees what the rest of the world is not ready to see. Until then,